matter.
But we have the
can
one
see
of
the page
5 at
number,
the
it's in
top.
the top.
Yeah, exactly.
That's true.
So David or do one of you guys want to try sharing?
I'm fine with what you're doing, Nancy.
Dang.
I think Dave went.
Not it.
Yeah, I'm putting
We have
them in
the
different
advantage.
modes
They got
so that it's
masks
not-
on.
We've only got
there we
an
go.
hour, and I have
This
it
should be better.
right at time right now. Do we want to go ahead and get started? As
Yeah,
people
we
continue
really
joining?
do need to start because there's a very, very full agenda.
You've got a few people here in the room, by the way. I know they look like dots, but
It looks like 5 or 6 people from here.
no, you've got about double that.
Oh, good. All right, let's go ahead and get started. Welcome to SUIT. We have a very, very full agenda today. And so we want to start on time with a hope of therefore ending on time. Next slide, please. Just a reminder of the note well. Given it's Thursday, you've probably seen this a lot, but if you're going to contribute, please make sure you're aware of what your obligations are. Next slide. So we have some administrative tasks, and I don't believe we have somebody agreeing to take notes in CodeMD. Could we have a volunteer, please?
We need volunteers to be note takers.
Well, we really can't proceed without this.
Well, in the interest of time, I'm happy to be a backup.
Yeah, Brendan, you're a presenter. You're not it.
No, Brendan's off the hook.
Yeah. Okay. Mike Jenkins volunteered. It would be
Thank
great
you,
if
Mike.
we had a second one.
Dave and I will watch as well. So
Awesome.
that'll get us there. Thank you. Next slide. So this is page 1 of the agenda, which is basically hackathon report, SUIT manifest, and how it has been broken up. And then firmware encryption. Next slide. And then SUIT report, and then SUIT related claims, and then MUD, which we just got added to the charter. So that's the intended sequence of events. Are there anybody who wants to bash the agenda?
No one in the queue here.
No, I'm not seeing anyone. I don't see anyone chatting. So, all right, Brendan, we're going to turn it over to you to explain what's going on with SUIT manifest.
And it was hackathon summary. So before we go into the slides, was there anybody that wanted to report at the mic about things that happened at the hackathon?
Yeah, we
Okay,
did not.
which one goes first?
SUIT manifest.
Hi,
Go ahead.
hi, this is Hannes. Just because of the hackathon, yeah, I was there at the hackathon, like many of the folks in like who obviously remote or many people couldn't come to this IETF meeting who are typically participating at the hackathon, which was unfortunate. So I've been working on the firmware encryption, and I'm going to talk about that a little bit later. So I think it was we had about, I would say, 100 people maybe at the hackathon. So it was well attended, relative to where we are today with the restart of the face-to-face meetings. So it's really good, but different experience than we had pre-COVID. So hopefully next time we'll get folks to participate in Philadelphia at in a bigger setup again.
See, it's getting cranky. I'm trying to share.
Okay, Brendan's up next with suit manifest.
There we go.
Okay, so this is the suit manifest draft. As you can see, it's still version 16. That means it hasn't changed since 1.1.2. Next slide, please. That doesn't mean we don't have any open issues. The primary open issues that we have today are MTI algorithms and crypto agility. Next slide, please. So it really makes sense to me that we should have some kind of PQC, mandatory to implement algorithm. But the question is, what does that actually mean? Does that mean that authors are required to support PQC, or bootloaders, or update clients, or all of them? I guess at minimum, it seems that authors should be required to support PQC. Next slide, please. So there are a number of ways. The one that we've discussed really is HSS LMS. Now, we have a research paper, which is linked at the bottom there, which has some details on exactly how this would be configured and what kind of implications it has. So comparing ECDSA to HSS LMS with the parameters that were selected for that particular research paper, we see 2/5 verification time, 74 times the signature size, 1.5 times the stack size, double the code size. I think that the key question here is whether a 74 times signature size is acceptable. This is 4 kilobytes, just for putting a concrete number on it. There's another parameterization, obviously, where we could do the W8 parameter rather than the W4. That drops the signature size to, I think, 1280 bytes. But I'm expecting a much higher verification time because there's a lot more hashes that have to be done. So the question is, can we realistically expect this from bootloaders? And I'm not sure there's a clear-cut answer on that. It may be that we have to specify that this is only a requirement for update clients. I'm not sure. Next slide, please. There is an alternative. Falcon 512 actually looks pretty good. It doesn't have the same kind of key management overhead. The signature size is smaller than all of the HSS LMS implementations, and it is incredibly fast. It does require a fair bit of RAM, around 4 kilobytes, based on the aforementioned research paper. The real issue is the code size, which is looking at about 57 kilobytes just to implement that one signature algorithm. And it's not yet accepted by NIST, though it is in the final round. So there's a possibility there. Maybe someone will come up with a better code size implementation. I don't know. I'm not sure what's driving that. Next slide, please. The next question is crypto agility. Now, that's quite plausible for update clients. Within the constraint that they will have to overspecify hardware, or implementers will have to overspecify hardware, and essentially be planning for this from the get-go. However, it's not plausible to have crypto agility in a non-updatable code. So how do we handle stage 0 bootloaders? Is that just a different requirement? We need to essentially say where our crypto agility mandate ends. And I guess the final question is, do we advocate for dual signature? The idea there is that you use a classical signature algorithm for the bootloader, but you use a PQC algorithm for the update client itself. Next slide, please.
That's the last slide
I think that's
have.
it. Yeah, that's it. So discussion.
David Brown.
Am I on?
Yes.
All right. So I guess the only comment I would make about something like 57 kilobytes of code is like several times larger than MCU boot is currently. And that's not going to work for, I mean, we can declare something as mandatory, but realistically, there are going to be config options and people won't select them if they aren't going to fit in their device. So I kind of wonder what mandatory is going to realistically mean.
Yeah, you're absolutely right, David. And that's exactly what I'm trying to highlight here, is that when we talk about mandatory to implement in the bootloader, we need to be really clear on whether it's even plausible in the first place.
So Brendan, I
And
had a
what that means
question
for the rest
about
of the chain.
that code. Was that a verify only implementation? Because I would expect that to get much smaller.
Sorry, which code?
The code size, is that for generating signatures or validating
No.
signatures or both?
Sorry, I appreciate that. The question was, are you talking about the Falcon or the HSS LMS implementation?
I'd be interested in both, but
okay. Well, on that one, if he's on the call, I will defer to either Kuhn or Emmanuel, since it was their research paper that I pulled this out of.
Go ahead, Emmanuel, and then Hannes.
Hi, yeah, Emmanuel here. Yeah, it's for both signing and verifying. And so we definitely, these are numbers we got with an implementation that we made as much as possible embedded friendly, but there are probably like ways to improve that, and we're actually working on that right now. We don't have the results for that, but I expect we can. I mean, as Russ said, we can do slightly better. There are some stuff which I think won't get better, like the signature size and things like that. But it might be that there are like more embedded friendly implementation out there. How much more friendly that is going to be, I don't know. But Russ is right that there's probably like some level of improvement that's possible here.
Okay, that's good information. My understanding from having looked at this a bit before was that 57K in particular seemed very large compared to what I saw on the site, the Falcon Sign site. I thought that it was possible to do smaller than that, but I took you at your word. So I'd be very interested to hear what the verify only sizes look like.
Yeah, definitely.
Yes, me as well. Go ahead, Hannes.
Hi. Yeah, I wonder whether it's possible to get away without specifying a mandatory to implement in this case, because as Brendan said, like there are different pieces in this or software components in this whole sort of picture. You have obviously the stage 0 bootloader or the one that is kind of the root of trust, and that's one thing. But then you have maybe other stages. In a more complex system, you also have the update client, which also has some code in there, and of course it will depend a little bit on the specific deployment case, like how long these devices are supposed to be out in the field, and so how can we make generic recommendations given that the NIST competition also hasn't been completed yet, and so on and so on. So like, do we really need to sort of like, can't we table that and maybe have profiles later on, for example, say a specific deployment sort of setup that has let's say a combination of different stages of bootloaders and firmware update client and so on, and have for those a recommendation versus something that is sort of very simplistic, short-lived, etc., or shorter-lived, a different sort of story.
Hannes, just a clarifying question. Are you suggesting that maybe we treat this in security considerations and leave it up to additional work?
Yeah, maybe to do more or less describe the challenge that someone deploying a firmware update mechanism has to go through. Like they have to sort of figure out for themselves on like how long are my devices going to be out in the field. Is post-quantum sort of the emergence of these computers, is that a problem for me, or do I consider it a problem? How much space do I have on the device, and so on and so on? Do I need encryption for my firmware, etc., etc.? Like, or how is my whole software architecture sort of laid out?
So I'm going to jump in and respond to that since nobody else is in queue. Right now, my prediction would be that if I were to look into a crystal ball, that it might not pass IESG review if it didn't actually have mandatory to implement stuff, because you would not have an interoperable spec per se if you required a profile that didn't exist in RFC forum to actually interoperate. And so I'm not sure that it would actually save us any time through the RFC process to try to split it out. It's a good question. You're making me think about it, but that's my guess right now.
Go ahead, Emmanuel.
Yeah, so I think that this question was raised because we wanted to make LMS mandatory to implement, right? Where there are like some questions about like, is that like today something that people are going to be able to do? And so the question is not like, do we want to have MTI or not? It's like, what do we put into MTI right now, I think.
That was the discussion, and we observed that we had this post-quantum HSSLMS opportunity, which would allow us to have transition to other algorithms under the protection of a post-quantum safe algorithm. So yes, it's a huge signature, but firmware loads are usually not small in the first place. So this is a place where you could amortize a large signature. I'm surprised about the code size. Okay, I think we need to continue this on the list. Oh, we have a new person in queue. Go ahead.
I just want to relay, we had a few other points of concern about the HSSLMS. One of them is that since it is not part of any of the like big standardized libraries, there is a greater risk that we don't know when we use it whether it will have support, whether security issues will be handled and fixed in the future. And also that sorry, I'm blanking. Well, that's at least one of them. But yeah, I couldn't remember the other one. Sorry. Go ahead.
Thank you. Brendan?
I just wanted to respond to the comment that firmware loads are huge. While that may be the case for a full image update, that does ignore that it's absolutely possible to do differential updates that are small. And it's also possible to do small asset updates that aren't the entire firmware image. So I don't think it's fair to say that amortizing a kilobyte or 4 kilobytes of signature size across a firmware load is necessarily going to get lost in the noise. I think that very much depends on the use case and on exactly what kind of compression you're using. And just to put some concrete numbers on this, the energy that it takes to transmit a byte of firmware over a LoRa network is, I think, on the order of 80 times the amount of energy that it takes to write it to flash. So when it comes to saving energy on low power remote nodes, the firmware size is like over the wire is absolutely crucial.
Good point. I think Emmanuel's next, and then Hannes.
Yeah. So I wanted to also violently agree with Brendan here. We detail like different different cases in this paper that Brendan was citing, where you see the impact of something like LMS in terms of signature size on the data you need to transmit over the network, depending on what you're actually updating, obviously. And there are different sizes indeed, where 4K is a lot. That said, so we we are working on improved implementation of LMS with our colleagues at INRIA, who are crypto specialists, so we're going to follow up on this paper with some more work, and hopefully we can actually bring some of these numbers down, not the signature size, but others at least. That's our hope, and so stay tuned on this. We'll get back as soon as we can on this. Thanks.
Thank you, Hannes.
Yeah, I wonder. We wanted to finalize the suit specification and manifest specification rather soon. So I wonder, like, what are really realistically the options besides HSS LMS? Because I don't think it would be wise to pick something that from the NIST competition which hasn't been finalized yet. Let alone that obviously there's even less code available. So that may be a little bit of a unfortunate situation in the end. I think that the choices are kind of limited, right?
It sounds to me like we have a timing problem here, right? That there's desire to make HHS LMS work, but we haven't had enough time for implementation to kind of catch up. One of the things that we did in IPsec-ME, was we had a separate algorithm draft that we would work on and update over time. And we use things like must minus or should plus as a way to signal a desire to advance or retract specific algorithms over time as a way to kind of signal to the implementation phase the direction that the standard was going. Maybe we could do something like that here as a way to, to break the logjam. Any thoughts on that?
Cohen?
No thoughts on that, sorry. I just want to update on the token numbers for clarification only. So if there's anyone who wants to respond to what we just had, then please go ahead first.
So you say 10K for Falcon verification. Did you look at HSS LMS verification?
No, so what I just did to get the numbers was quickly take the benchmark, the test application we have for Falcon, comment out anything that's related to key generation and signing, and grab the numbers from the ELF file that take up the Falcon bits, and that's around 10K. So that's for Falcon probably what you have to work with for this implementation if you want to have it in your bootloader added.
Thank you. That's helpful.
Yeah, I can get you numbers for HSS LMS, but that takes around a similar amount of time for me to get those.
Okay, thank you.
Okay.
Hannes?
Yeah, I like the idea that David just raised, but the problem is it sounds like a little bit to what Dave Taylor was previously referring to, because we basically then have no MDI in the manifest specification, move that to a separate algorithm draft, but then presumably they would have to go together, right? While there's a benefit of having the ability to update that algorithm draft independently without sort of revising the manifest specification, which is attractive to me, but I think it will not sort of like really allow us to get us off the hook of the question of what MDI is, because even so I haven't looked at that IPsec draft, but presumably it also has an MDI version in there, right?
This has been done for lots of protocols to separate the algorithms out just so they can be revved over time without changing the base protocol spec.
Okay.
SMIME, IPsec, TLS, lots of them do it.
But the TLS doesn't. But
No,
I think it's a
TLS
good
kind
idea.
of puts it in the IANA registry with the recommended, not recommended thing.
Yeah. No, I like that idea. But even then, like, would it make sense to, let's say, have ECDSA in there as, for example, currently as the must and a recommended or should for HSS LMS, and then as we make progress and say, okay, we can get the code size down and we can do all sorts of other investigations, we revisit that document and then maybe make some other recommendations. Is that sort of the idea, David?
The idea, and that would allow implementations to catch up, and we could make better decisions, you know, at some time down the road.
Okay. Yeah, I like that.
If anyone thinks that's a bad idea, please put something in the chat or come to the mic.
Brendan Moran here. So I think that honestly, the direction we're going to have to go here is to specify an MTI for update, but not specify anything for boot.
That could still be done as Dave suggested by putting it in a separate document that's a normative reference. That's easier to change without ever changing the base spec.
Yeah, fair enough. I guess what I'm trying to say here is that bootloaders can end up being so application specific that if we are too normative about what the bootloader does, all that means is that this will not get used in a bootloader and will inflate sizes artificially because there are multiple manifests flying around.
Okay, Hannes, is that a new hand or an old one? Okay, so I think we have a basic direction for Brendan to finish this up, and it's very clear that we've spent half of the time on one document, so that we're not going to get anywhere close to through this agenda. So we're just going to keep going because I think the decisions we're making are important, but we're going to be scheduling a virtual interim in a couple months. So let's keep going. Brendan, up next is the trust domains.
Okay, so there is not a lot of update here. This is just the resubmission of the previous individual draft as a working group draft. Next slide, please. Just as a quick recap, this is the portion now that contains delegation chains, dependencies, integrated dependencies, multiple suit processors, and the unlinked directive. Now, this is important specifically for TEEP, so we want to get this one through quickly, quickly after the manifest primary document. And it is specifically because TEEP depends on dependencies and unlink. Next slide, please. Now, I say that there's no running code for these things, but to be frankly honest, I could well be very wrong. I know that Akira has been working on running code, which may well do all of this. So when I say there's no running code, I mean that I haven't spotted it yet. So if there is running code, please do let me know. Really, the other thing is I'm not 100% certain that we're using the CWTs correctly. So if there's anyone who is who wants to review the use of key claims in CWT, I would appreciate that. Or sorry, proof of possession claims. And I would very much appreciate any contributors, and especially if they come from TEEP. I mean, anyone is welcome, but if they come from TEEP, doubly so. That's all I have for this document.
Basically, I'm hearing a scream for review.
Yes, please.
Yeah. Any comments from anyone who has either implemented or read the document? Seeing nothing, let's go on to the next one. Whoops, here comes Ken.
Hi, Brendan. Can you hear me?
Yes.
Oh, yeah. Yeah, as I mentioned in the chat, my libc suit support dependency and also integrated dependency, but I'm not sure it actually supports because there is no sample binaries in the document. So I will put an email. So please review my sample binaries and also libc suit parser behavior. Thanks.
Thank you, Ken. I guess what that really says to me is that I need to make sure that there are some examples in that draft.
Okay, I'm not seeing anyone else in the queue. And let's go on to suit update management.
Okay, and once again, this is a resubmission from the previous individual draft. Next slide, please. All right, just as a refresher, what this contains is update management metadata. So this provides information like certain conditions that you might care about, version number matching, battery levels, expiry dates of manifests, an explicit check for if an image does not match something, and an authorization check, which could be used for end user approval. And I think that's an important consideration with RFC 8890. You want something that allows the end user to have some degree of control. So that one fulfills that particular requirement. Then there's also directives for managing updates like wait for event and metadata for non-recipients. Next slide, please. So currently we are specifying COSWID, which is what was available when the original draft was written, but it looks to me like CORIM would be a much better option. The problem is that CORIM is not a working group document yet, and so that would essentially put a blocker on this particular draft. So it strikes me that it might be better to go ahead as it is and add another extension document later, much as I'd rather not have so many extensions. It's not clear that the update management document is anywhere near comprehensive or complete. Once again, if there are use cases that you care about, I would very much appreciate hearing about them. Feedback is absolutely welcome. If you want to contribute, please do. And that's all I have for this one as well.
Again, a big call for review, and
there's going to be a common theme.
Okay, seeing no one join the queue, up next is Hannah.
Okay, next slide. Briefly talking a little bit about the firmware encryption. So what has changed since we met last time? So there was this intra meeting in the COSI working group where we presented the COSI HPKE draft, and there the decision was made to change the underlying structure of the payload. Needless to say that had to be backported, so to speak, into this document. And I've also fixed references, which apparently got somehow garbled. We spent most of our time focusing on progressing the COSI HPKE, which we extracted from this document or from an earlier version of this document and moved into that separate document per the last IETF decision of this group. Okay. And in the meanwhile, I had added code to HPKey to embed TLS, which you can find there. I'm using that code in the dcosi library, which you find there, and updated the code during the hackathon, which I was previously referring to, which uses this the crypto adaptation layer that Lawrence has added. dcosi supports OpenSSL and also the BSA crypto API, which is why I had used the BSA crypto API. What you will also notice when you look at that code is that the firmware encryption is for use with AES key wrap is not yet there because the BSA crypto API support for the AES key wrap is still work in progress in the last link here. So as soon as that is done, I will copy that code in there as well. Okay, so there's at least something to look at, and that's how I created the examples as well. Next slide. So, but there are some open issues still, not only with this document, but also with the work of the COSI HPKey document. So we will have to work on or take the decisions that were made earlier this week in the COSI working group and update this document as well. The examples are kind of rudimentary, so they don't include, for example, the whole wrapper, let alone the suit part, sort of like the outside manifest part, which I would also like to include. And there's also sort of some homework to be done when it comes to binding the context to the encryption itself. And I want to talk about the last two items in the next few slides briefly. Okay, next slide. So this is what I mean by a more complete example. So what you see in the document right now is the left-hand side, which shows this COSI structure in a sort of debug format with this new two-layer structure, which is essentially the sort of the first layer. The first part on the top is just the regular encrypt functionality, COSI encrypt with algorithm information with the nonce included in there, detached ciphertext. That's the first part. And then what follows afterwards is the recipient structure, or if there are multiple recipient structures in that array. And that's, for example, where the HPKey goes or the AES key wrap. So this is now unified in terms of look and feel, which I personally like a lot. There's obviously some of the things are abbreviated for better readability. So obviously the keys, the public keys, and also the encrypted keys would be larger. This, however, needs to be, in order to provide proper security, or at least the authentication part, it needs to be bundled up with a sign. So as I tried to show here graphically, is that once you generate this cozy encrypt structure, it gets sort of, the binary gets included into this payload structure on the right-hand side of the slide. And then the cozy sign wrapper is, sign1 wrapper is then used to actually sign that payload. I hope that makes sense. So for example, if you have, not for example, but this would be the way to be done for the use with the HB key when you sign it. But then with key AES key wrap, when if you have a shared secret, well, in this case multiple shared secrets, then you would actually use the MAC operation instead. So that's those are some of the examples that are still missing in the document. I will add them as well based on the code I have. Okay, next slide. So if we actually produce that example on the previous slide, there is the sort of, for the topmost part, there is the encrypt operation, which for which the COSI specification defines that you have to come up with a structure, which I copied on the screen, this enc underscore structure, which is then used as input to the additional authenticated data for this operation. And so there's some context in there, namely the operation you are going to perform. There's also information copied over from the protected field, which is from, for example, on the previous slide, we used AES GCM 128 to encrypt the firmware image, so that would be put in there. And then there's, in our case, there's no external AAD here. So this would be used, and then that would be input to the regular, in this case, AES GCM 128 operation, and that's what the output would be. Next slide. But there's more than that. So the COSI spec also talks about this so-called context information structure and refers to sort of it as a way to bind the context or the context of the transaction to the whole sort of construction, if you will. And as far as I understand it, and my reading of the COSI specification is a little bit, I'm still learning in some sense on how to read that COSI specification, but I understand that it's not used for AES key wrap, but it would be used for, or it's currently used for all these elliptic curve Diffie-Hellman static or semi-static operations. And so that's why I had put that sort of a way to populate that structure into an earlier version of the document, which is now found in the COSI HBKE document. So I have spoken to a few folks during this meeting about how they interpret that text in a COSI specification, and it's not entirely clear. So I'm going to reach out to some of the experts here in the IETF, like Carsten and others, to find out whether my understanding is correct. But it's a little bit tricky because I don't want to have too much redundancy here, because some of that information is already included in the KDF, in a key derivation function of the HBKE itself already. What is not included is, because we are using the base mode of HBKE, is the identities. So at least at the minimum, we would have to wrap in the identities. And the recipient identity itself, as if actually we could go back to slides to show to see the example here. No? Another one? This one? Yeah. So if you look here, there's the key ID shows here up in two places, and one is for the sender and the other one is for the recipient. So in the COSI encrypt that contains the recipient, the key ID for the recipient, I don't know if you can scroll over if you have a way to mark things, but you can see that if you go down with the mouse point a little bit. So as part of this recipient structure, there's the key ID that identifies the static elliptic curve Diffie-Hellman public key. And that would be the recipient ID. That would be, yeah, exactly. That would be the recipient identity included into this structure. And what is a little bit inconvenient is that since we have this layering of the payload, the sender's identity is actually outside in this COSI sign1 structure, but that's how it is. So if anyone has an idea on how in COSI this was meant to be used, being applied to HPKey, or has some other sort of like experience with this, I would obviously value that input. But I understand it's a little bit a very specialized aspect here. And yeah, so this is definitely
so
an
Hannes,
issue.
this is Russ. This goes back to RFC 2631, which is based on ANSI X942, where you're trying to derive a shared secret, and you want to make sure that both parties are applying the same context to that secret. That's where this InfoStruct stuff is rooted. And here we've got a lot less concerns because of it's always used with the signature. So the question, to my mind, really falls to the COSI group to make sure that when they're using it as a building block in other contexts, are there any concerns? And I think we need to make sure that question's raised there. But in this context, I'm pretty sure there's no problems.
Yeah, that was my impression as well, because I don't want to sort of blow things up with some redundant payloads that are actually then not adding any additional value. But yeah, so currently, what is currently in the two documents is that we don't use that structure, and the COSI HPKey document says, if you have an application-specific context, here's the structure and you populate it with the respective fields. But I want to sort of be sure that you guys agree with that. That's yeah.
Was that your last?
That was my last slide. Yeah.
Yeah. That one.
So if anyone is interested to contribute, drop us an email. Yeah, code there. A lot of fun.
Are there any further comments? Okay, hearing none, we're going to go back to Brendan for suit report.
You're on mute, Brendan.
Got it. Thank you. So once again, this is an update. This one actually does have new content. Next slide, please. So just a quick recap of what this is. It carries a record of decisions made by the suit manifest processor that you use alongside the manifest tree itself in order to reconstruct what a device did. Decisions are appended to a log, essentially, in the order that they're made. And if you want to make this efficient in a small device, you can use indefinite length encoding to construct that whole CBOR structure on the fly. Next slide, please. So what we have done since the 00 draft is added a list of suit parameters and component IDs to use as system properties. What this can do is it enable attestation of system properties, though it does have wider applications than just attestation. And it ties into the suit reporting policy, which shows up in the manifest draft itself. Next slide, please. Oh, that is the last slide.
That-
Oh, okay.
I was gonna
Right.
say that's
Yeah.
your last
Sorry.
question.
Yeah. Sorry. I had originally planned to have this one come after the one on the suit and rats claims. So that's hence my thinking there was more content coming there. So this I guess sets the backdrop then for that particular discussion. So I think it makes the most sense to me to put these two together, and maybe we should go straight into the next one, and then we can have discussion about them together, because I think the issues really are tied together.
Okay, then let's go to draft Burkholtz rat suit claims. The slide deck is called Suit-Related Rats Claims.
You want me to switch?
Yes, please.
Yes, please.
Got it.
Great. Next slide, please. Okay, so previously we had a draft of suit claims in rats to define suit-specific elements that require attestation. The thing is that the suit report could also carry these elements. Now, we proposed this at the rats interim and suggested that we merge this document with the suit report document. Now, that was rejected in the interim. And the reason for that was that some of the claims are duplicated by elements that have been added in rats. I don't think that this is the correct decision, and I don't believe that Hank does either. And I want to revisit that with some additional explanation of what our reasoning is, because I don't think that we managed to carry that across properly during the interim. Next slide, please. So essentially, this is a debate about semantics versus structure. EAT contains data with specific semantics and specific structure, and the suit report contains data with similar semantics and a different structure. The suit report structure is designed specifically to reduce overhead on constrained devices. Now, what that means is essentially that you don't have to hold in memory components that will go into the EAT claims later. The idea here is that you can actually just directly encode on the fly as you encounter these decision points. This may seem like it's a premature optimization, and I suppose it might be, but it's consistent with the non-attestation side of reporting in suit. So by putting those two things together, it seems that they do make sense on their own. Like the joint code size reduction and memory reduction that you get by doing both things this way seems like it would be the right choice. Obviously, this is something that we don't have measurements for yet, but that is something that makes sense to me from a high-level perspective. It's really tightly coupled to how suit parsing is done. It happens in exactly the same order. And so eventually we get down to the heart of the matter, which is that it's got similar semantics, but different structure for a reason. Next slide, please. And so this is where I think we come to possibly the contentious side of things. Suit reports could potentially be treated as evidence, but they should not be treated as attestation results. So arguably, a verifier should translate a suit report into generic EAT claims. So now we look at these as two different pieces within the RATS architecture. And so this is why we believe that it makes sense to add one claim to EAT, which is a suit report. Next slide, please. Oh, I just stole my own thunder. So that would be consistent with using it as evidence. The verifier would be perfectly capable of translating claims from evidence to results where appropriate. It moves the format translation overhead away from constrained end nodes and puts it in a verifier in a data center somewhere, which is where it belongs. And it would allow us to merge the suit rats claims document into the IETF suit report document and then only have one claim added in EAT, which would cover all of suit. And that is my slide deck. So questions, comments?
Go ahead, Dave.
Dave Thaler as individual participant and editor of TEAP protocol. I think this is part of the right question. What you have on the slide might actually be the answer, but I wanted to up-level the question into multiple possibilities and maybe get your feedback and the rest of the working group's feedback to see if this is the right one, because I can see multiple different ways one could go. That I think are consistent maybe with your original principle, and this is one way to implement them, and it might be the right one. Okay, so I can imagine for completeness, I can imagine you could use the suit report as the evidence format, say instead of EAT. Okay, you could use the suit report in evidence, like encapsulated, like you have here, which is you're doing it inside of a single claim, inside of an EAT, right? So you have a suit report inside of an EAT. You could do it translated, where the information in the suit report becomes information in the EAT, and I think that's consistent with what you're saying maybe about attestation results or portions of attestation results and portions of suit reports maybe. You could also send the suit report in addition to evidence, and it gets to the evidence is stuff that is interpreted by a verifier, and here in the TEAP case, the thing that needs the information in the suit report is the relying party. So you can say, well, how do I get the information from the attester or suit reporter into the relying party? And so you might be able to do that via inside the attestation exchange, in which case all the information that's needed by the updater, it has to be in the attestation report in some way. So you got to go through that pipeline. Or another way that you could do it is to say, okay, independent of attestation, you send the suit report directly from the attester to the relying party, which means it would be in the TEAP case, that would be in a query response message separate from the evidence field. Okay, and so in terms of what we do in the TEAP protocol spec, we could add another field into query response that says, here's how you could reply. Here's how you could pass in, the boot time suit report or something like that, separate from the evidence field. Or you could put it inside the evidence field, but then you got to make sure it gets translated into attestation results just so that the TAM could get it, rather than getting it in parallel to the evidence. So those are the different possibilities that I see. I have no objection to doing what Brendan is saying here on the slide. I just don't know if that's the most efficient way to do it in TEAP, or if we should also have a way of having suit reports directly in the query response. In the query response, in addition to the evidence field, just so it goes directly to the relying party, and it only pays attention to it if attestation succeeds. So open to feedback.
Hey, Dave, real quick. You said a lot, and it was very difficult to capture in the notes. Would you mind typing some of that into the notes for us?
I would be happy to, although it would be more concerning if Brendan didn't understand my question. So
no, I did understand your question. It does make sense to me. I can see I think it was 4 different ways that we could go about this. The argument I'm making is that it doesn't make sense for a constrained node to have to do claim translation when that could easily be handled by something higher level.
One of the questions is tied in, and I know we're just about up on time here, and so we may have to defer this to the list, but I am looking for direction as to what to do in the TEAP protocol one. Is today, there is no requirement for a TEAP device, a TEAP agent capable device, to actually keep track of suit reports at boot time, right? You can argue that there is a requirement to keep track of suit reports at update time, okay? But there's not currently a requirement to keep track of them at boot time. If we say that there's no claims directly in EAT, then I think it does introduce a requirement to have suit reports at boot time, and there would be a dependency there, a requirement for the TEAP agent. So,
yeah, I think on this one, I'm a little bit less concerned about what happens in TEAP. Because so far, at least, it appears that TEAP devices are typically larger and have more power available, more code size available, more memory available. So maybe that's not quite as big of an issue, and it's fine to do things the way they are. I guess I'm more thinking about more constrained devices. I think this is something we need to discuss on the list a bit more. So maybe we should defer, or we should take this discussion to the list. I think we are out of time.
Yeah,
as
given
a
that we're in
chair,
our
yes,
last
all time.
minute.
Yeah.
So yes, let's continue this discussion on the list. I'm really surprised, given that the first presentation took us a half hour, that we got through this much of the agenda. But yes, let's take this to the list, and we'll schedule an interim so that we can recap what we do on the list, reach consensus, and then talk about MUD. So expect a doodle poll soon. And for those of you in Vienna, safe trips home after the meeting ends tomorrow. Thank you very much to the note taker, especially.
Thanks, everyone.
Thank you.
Thanks, everyone.
Okay.